Prof Sheila McBreen, welcome. You're a professor in the School of Physics at UCD. You completed your PhD back in 2004 on the subject of the prompt emission of gamma ray bursts. After graduation, you worked as a research fellow in the European Space Agency in the Netherlands. In 2006, you were awarded a Marie Curie Fellowship from the European Union and moved to the Max Planck Institute for Extraterrestrial Physics in Munich. You're a member of the AirSat-1 team and have been awarded a Science Foundation Ireland Career Development Award, and more recently, an SFI Frontiers for the Future Award. So there's much for us to talk about today. But before we get into the actual research, I'd love to, we always start here, and it's just to ask you a little bit of your journey to here, maybe where you're from, how you started out, and what led you to where you are today.
Yeah, no, so I did my undergraduate, I'm from Dublin, so I did my undergraduate in UCD actually in physics and computer science. So there was no astro in there. There was no astro degree at that point in UCD. So I did a joint degree in computer science and physics. And then after that, I actually took a year out and did an internship for a year. And at that point decided I wanted to go back and do my PhD, and that was in astrophysics with Professor Lorraine Hanlon in UCD. And yeah. And I've forgotten the title of my PhD, actually. You've reminded me of it there.
It's been a while.
Yeah, it has, yeah. So that's what I did. And then after that, as you say, I did postdocs in the Netherlands and in Germany.
Yeah,
so,
yeah, which is that international connection we'll come back to, actually. But did you always know you wanted to do astrophysics or physics? No.
No. I mean, I think when I was in school, certainly I always thought I would go towards the sciences. And at that point in UCD, it was the common entry, which we still have, which is a great program, I think, because it allows you to come in and do multiple options and have pathways available to you, which I think is really important. I mean, I thought that I would do chemistry, and then I preferred physics in college, and I think that's a common experience among people. And I think it's really good not to have to make that decision while you're still, contending with the leaving cert and, quite young. So from my point of view, then I went more towards physics. I thought I would stay with computer science, which is a skill which is always valuable, so there's no harm in that. And then after that, I decided to do the PhD in astrophysics. And it was a bit of a challenge because we didn't have astrophysics undergraduate courses, so there was a lot to learn. That's changed now for people coming in, but there was a lot to learn during the PhD, I found, and since, obviously, as well. Yeah. You don't know everything at some point. So yeah, that was my path.
Yeah, and astrophysics, exactly. It's not an obvious path necessarily. Lorraine is amazing at UCD, and I would imagine a big influence as well. Tell us a little bit about where you're at today and the research that you're working on today. I mean, where do I start? But and maybe to explain a little bit about gamma rays and gamma ray bursts.
Absolutely, yes. So I mean, from when I started doing my PhD, I became interested in gamma ray bursts. So gamma ray bursts are these really short. When we say short, we mean of order 2 to maybe 20, 100 second long events. And what they tell us is that there's been the death of a massive star or the merger of smaller compact objects like neutron stars, which are really, really dense stars. And we get these signals, and in order to get these signals, you have to build detectors capable of doing it. And because our atmosphere absorbs gamma rays, so gamma rays are higher energies than X-rays. People will all be aware of X-rays from getting an X-ray on a broken arm. They're higher energy, which means shorter wavelength. So they will then penetrate more. And the atmosphere, the Earth's atmosphere prevents them coming down. So we have to put detectors in space. So at that time, when I first started doing my research, I was using the NASA Compton Gamma Ray Observatory. That was where the data came from at that time. And I did my work looking at how these light curves, so how they changed with time, and whether we could learn anything about the sources from that. And then after that, I moved to the European Space Agency. I got a research fellowship there. That was a fantastic experience to go to the Space Agency. I really enjoyed that. It was very different to a university environment. I met a lot of good friends working there. It was very international. Living in the Netherlands was fantastic. And from the work point of view, then I made a lot of contacts who I would still talk to and see from time to time. And then while I was there, I applied for the Marie Curie Fellowship, which brought me to the Max Planck with the very long name, MPE for short. That's in Munich, just north of Munich. And there I branched out a bit, so I joined the NASA Fermi gamma ray burst monitor team. So that's an instrument which was actually a follow-up to the one I did my PhD on. And I joined the team, so the German part of the team, it was Germans with Americans, and it was a collaboration to build that detector. And when the time I arrived, it had just been delivered, and it was launched then while I was in the Max Planck. So we were very early on. It was a real learning curve, you know, understanding the data. Everything wasn't as mature as it might be now. We were doing shifts, monitoring the events coming in, writing notices so people would know about them. And that was really an amazing experience, joining that team and working in Germany as well.
Incredible. And I mean, I'm thinking you're now based in Ireland working on similar areas. And I think you touched on it there, but I'm assuming like when you're working on a small island on the edge of Europe, those international connections must be absolutely crucial.
Oh, they are. They're absolutely crucial. I mean, space is not an area really where you can work in alone. It's where you work in teams. These teams are international. Detectors have to be built, tested, put on rockets, launched, operated, all of it. It's a huge endeavour. And joining teams, you know, there's another aspect back to that, which is CubeSats, which I can come back to. But from the point of view of the large missions, you need to be in a space agency to be doing them. The European Space Agency has its programme, and then NASA has its own separate programme, and then sometimes they work together as well. But being on the inside of one of those instrument teams was just a fantastic experience. You know, from the science point of view, you interact with a lot of people. You learn about things to do with spacecraft that, you know, as a PhD researcher working on the data that just appeared in an archive, you didn't know. You know, and there's still things sometimes that I hear, you know, someone would say something, and I would think, you know, actually while I was, you know, doing my PhD, I never understood what that was. And now I understand what it was because I was on the other side of the fence, so to speak. And it was a wonderful experience. So many colleagues down through the years that I've worked with and I'm still in touch with. And my students are still part of the team, still working in the Fermi GBM team, which is wonderful.
Fantastic. And you're a member of the AirSat-1 team as well,
Yes.
Based out of UCD, I think. Tell me a bit more about that for our readers.
So I talked there a bit about the large missions. Yeah. So the large missions, you need to be an international team. They're really expensive. You know, they can be 20 years in the making. And then for AirSat, it's different. So AirSat is what's called a CubeSat. So CubeSats are relatively new. So they're really, the idea was that they would be modular. So it's 10 centimetres by 10 centimetres by 10 centimetres is 1 U. And then they're built up in U's. So AirSat is a 2U, so it's about that size and about that, like we always say, kind of carton of milk type size. And it's something that you can do in a smaller country and you can build in-house. It's extremely challenging because everything that the large satellite does, you know, with a few exceptions, you're going to need your small satellite to do as well. So there's a huge learning curve involved, but it's something that you can reasonably, from a cost and time and experience perspective, undertake in a university. And for us, we joined, there's a program called the European Space Agency Fly Your Satellite Program. And that runs a program where you can put in a proposal, which we did in 2017 with our idea for AirSat-1. And it's student-led, so the students presented the project and it was accepted into the program. And since then, we've been working on it. And the European Space Agency membership is absolutely key to all of this. So our access to the FYS program, access to their labs, they help us with testing. They, you know, train the students while they're there so they can learn how to do it. And then when they graduate, they can then, you know, implement these things in Ireland, for example, or work abroad for a while, come back. You know, it's huge experience and things that we hadn't done. Yeah. You know, we brought our gamma ray detector over there for thermal vacuum testing and for vibration testing. And, you know, they helped us figure out what the levels should be. And in UCD, I should say, the AirSat team, so I think I looked yesterday, there are about 50 students involved overall through the years. So not everybody is still there now. There'll be masters and PhD students in physics, engineering, and also a few in computer science. So it's quite a interdisciplinary collaboration. Yeah. And that's the way it is in space. You can't, the physicists can't do it on their own. The engineers were always joking, you know, with each other about being a physicist or being an engineer. But the reality is you have to work together, and their experience and our experience joins together to be able to build something like this. So it's actually ready for launch now. It's just waiting for its slot to get into orbit.
And when are you hoping for that to
We
happen?
hope in the next, you know, 6 months or so,
wow,
but
okay.
we just have to wait because the rockets are not that frequent.
No.
So the next available opportunity, and it's sitting there ready to go, the flight model.
You just have to wait for the next rocket.
Exactly. Yes, indeed. Yeah.
You need patience when you're working in astrophysics.
Yes, you do. Yeah, it's not that easy to get there. So
no. And it's fantastic. Yeah, how you explained the AirSat team there and that access it gives to the knowledge, and then linking in with the European Space Agency. And I mean, you see, there's lots of small space kind of technology companies coming out through EI and you name it. I mean, can Ireland can be a player in this area?
Oh, absolutely.
Is Ireland a player?
Yeah, I mean, we are a small country, so we do have to think about being part of collaborations in terms of the science in particular. There are a lot of companies which have been supported by Enterprise Ireland, as you say, and there's a space strategy for enterprise that was launched about 5 years ago, I think, in Ireland. And also, you know, from our perspective, we would love to see a space policy and research as well, to really bring together all that work that's going on in astrophysics and Earth observation and all those areas that are related to space in Ireland. I would, you know, personally looking at Ireland, you know, from my side, I would love to see, you know, a space office or a small space agency. A lot of the smaller countries do have space agencies. We do have colleagues who work and they do a fantastic job and they're located in Enterprise Ireland. But I do feel that if we could have that separated out, because it's a very different endeavour, you know, space, it's long term, and we can't just kind of do it on a year by year basis. It's very difficult. I mean, we've sort of done that with AirSat, but it was a really, really challenging experience. A lot of the projects, you need to have people around for the longer term. And also I think that that would be a fantastic benefit to look at how other small countries are doing in that area.
Okay, so here's to another
and we are
space
building,
agency.
yeah, I mean, we are building up capacity in Ireland all the time. Like in UCD, we have the Space Science and Technology Masters. So we have our undergraduate degree, which is Physics with Space Science, Astrophysics and Space Science, and then we have the Space Science and Technology Masters. That's a one-year taught Masters, and I think the numbers that we have now is probably about 80 or 90 graduates, maybe more already. Wow. So it's about 10 to 15 per year, so we're slowly building that up. A lot of those graduates then work in Irish industry, or they might go abroad. And they do an internship, so we're certainly building it up from both sides, I think, in terms of building a space sector.
And that latest award is going to help, I hope, because you're hoping to kind of widen the access to sort of research data through the Frontiers, I'm going to get the name wrong here, SFI Frontiers for the Future Award. It was only announced there recently. But tell us a bit more about that and how that could also...
Yes, so that actually, around the time where we submitted AirSat, I got an SFI Career Development Award, and that was the precursor for me in combination with AirSat. So in that award, we put a gamma ray detector on a balloon flight with colleagues in NASA. So I flew out of the Columbia Space Balloon Flight Center in Palestine, Texas, and it went on an 8-hour balloon flight. And that was the precursor grant to demonstrate the technology in a near space environment. 37 kilometers, as high as you can get without a rocket. And then, so after that, then I went back 4 years later and put in the Frontiers for the Future one. And what I want to do with that one is to build a 6U. So AirSat, it's basically 3 times AirSat. And in this case, what we want to do is have a bus in the middle, which would be kind of the size of AirSat, and have gamma ray detectors on either side. And the gamma ray detector that we weren't putting there and that we're working on at the moment will be a bigger detector than the one that is currently in AirSat, and there will be more of them. So the idea behind that is you would be able to not only know that there was an event, but tell a little bit about the direction of where it came from. So that way you can work with other people from other telescopes and tell them that you detected it in that region of the sky, and then they can follow up or tell you whether they detected something or not. And that's really key in this. So we're in the multi-messenger era now in astronomy. So this is the gravitational wave era. And Observation Run 4 just started actually 2 weeks ago perhaps. So this is the LIGO, Virgo, and all those detectors which detect gravitational waves, which is amazing. They were predicted for a very long time, but the technology to detect them, I think the first detection was 2015. So what we're looking for now is to find ones that are coincident, and that tells us what the event was from the gravitational waves. And then we can tell more from the gamma rays, and we put the picture together. And that's really the area where I'm kind of going with this Frontiers Award.
Congratulations, that's very exciting.
No, it's very exciting
for the people who get to work on it.
Yes, no, it's fantastic, and they're great students out there, so we're very lucky to have them. And looking forward to making progress. It is difficult, it won't be easy. It's challenging, so, but we'll keep going.
Astrophysics, it was never going to be easy.
No, that's true, that's true.
Tell me a little bit as well, you were a co-proposer for the Centre for Space Research, which I think launched during the pandemic, am I right?
It did, yeah. We were trying to wait, but in the end we ended up having our picture outside on the chessboard in UCD. So that's called C-Space, Centre for Space Research. So that has followed on from a lot of work we've been thinking about really for over a decade, about consolidating all the different work that's going on in UCD in space. That's in physics, astrophysics, engineering. They have the dynamics group, space materials, then Earth observation as well, and then also we have a strand in it on training and education. So it's really very broad, and what we want really is to consolidate all the work in UCD and then work nationally on, pushing for more investment and more outputs in space.
Brilliant. Tell me, I mean, we can't have this conversation without me bringing this up. You're a woman in physics. You've also been a very strong advocate for women in physics and in science. I think you were on the original team that brought Athena Swan to Ireland. Am I right? You were one of the volunteers.
Yes, you're one of the original. Yeah, it takes me back now.
Yeah. You're not as young as you look. So tell me about that. Tell me a little bit about the history of being involved in Athena Swan and the various projects afterwards. And above all, I'd love to know from you, it's an area that's very close to my heart as well. I mean, have we seen progress? Are we seeing progress? And what more can we do?
Yeah, it's a tough question. I mean, it's an interesting time to ask it because we are now moving from physics temporarily in UCD. We're phase 3, which is a big project to build 2 fantastic new buildings. But in the process, we have to move out for a while. So I've been going through old things in my office and finding documents from back then when we set it up. So the first iteration of that was Women in the College of Women in the Sciences, WITS, in UCD. There's another WITS, which is the national one, but we were the UCD first, and there were 4 of us who worked on that original committee. It was myself, Patricia Maguire, Jennifer Mitchell, Maria Meehan, and I think that really where it came from, everybody really. There was an original meeting that Joe Carthy called, and he was Professor Joe Carthy. He was the principal of science at the time, and he was really supportive. And he called a meeting of all of us together, and we all discussed what the problems were, and everybody realised how many they were, and that they weren't the only one really experiencing these problems, and that our promotion rates were not good. The number of women in science was not good in general. It was worse in some places like maths and physics, but also in the other places that maybe there weren't as many senior women as there should be when you looked at the numbers. So really, and it was about how difficult it was to find those numbers as well. And then separately to that, I can't actually remember how I got involved in the national group of volunteers. There was a bunch of us. We used to meet up every few months and try to push the agenda on it, and we all worked together. It was such a collaborative group, and I met a lot of really great colleagues in different disciplines nationally. And eventually we got in touch with the HEA, who were hugely supportive, and then eventually we got the funding for a 3-year pilot of Athena Swan to Ireland. So we had the Athena Swan people invited over, and we met them, and that was really the start of it. And for us, we sort of felt, and I think nothing is perfect, and some people feel that maybe there's too much focus on, perhaps box ticking, and I can understand that completely. But from where we were coming from at the time, there was really no way to find out anything. So this at least brought in a framework, and it was a framework where it was externally evaluated. So you submit your Athena Swan proposal externally, and it's evaluated by a large committee. And I actually don't know the numbers now, but there are a huge number of departments now in UCD and nationally, and UCD has a bronze medal, I believe, from Athena Swan. So there have been, there is huge progress. I do see progress. I think for me, obviously I did physics and computer science. And it's funny, when I look back, I don't think I really thought about it, to be honest, when I was younger. It just was, that's the way it was. I went to a mixed secondary school. I was the only girl in the physics class at the time. And that was it. And you got on with it. And then as I got older, particularly when I had my first kid, I realised this is ridiculous. I just couldn't believe that it wasn't automatically the case that I would get cover. And this is 2012, this is not in the 60s. And, these things, they really hit me. And then I began to talk to other colleagues, and I realised, they had it actually worse, and I just felt that we are not going to make progress unless we tackle these things, because it's not gender neutral. If you're out for, 6 months to a year, it has an impact. And I also felt strongly, and I still feel as well, that I think we need to get away from this, superwoman complex that somehow you can, and I did it myself. I submitted proposals in maternity leave because I had no choice. But we need to get away from that being standard. Where people are really, it's amazing you did all these things, but what is the cost? And I think it's really important that we get away from that. So now we have maternity leave cover, we have a research semester for colleagues who are on maternity leave, and sick leave, other types of leave as well. And we have other, and I do think the situation is improving. I think we can't be complacent. I mean, in physics, I think we've come on great in UCD. We now have 3 females who are prof or above. We're on our 2nd female head of school, Professor Emma Sokol, and we have 3 new colleagues who were hired in the Ad Astra programme into physics. So I think there's 8 of us now, which is fantastic.
Yeah, that's progress.
Yeah, because we can't talk about representation and all of that unless we have the people to do it. And I think that's really key. you know.
It's amazing to think like that things like maternity cover as recently as that were.
Yeah,
even
they were
had to be
not
brought up.
automatic.
Yeah, it's shocking, isn't
It
it?
is, and I think that I think it'll be hard to know exactly. I just hope, I don't know how you measure the effect of that. I think we'll see it in that the younger female colleagues will just have a better time, I hope.
And what about young women going into physics?
Yeah.
I mean, like going back many, many years, there wasn't even a physics option in my school down in Kerry. Like, are we seeing the pipeline improving?
I don't know really from the secondary school perspective. I mean, certainly within the university, like people can do physics if they haven't done it before, so that is an option. Our numbers, you know, I led the Juno project and I went back and looked. I don't know how our numbers are now, but when that was submitted a few years ago, you know, we were somewhere between probably, depending on the discipline, 20 and 30%. Astrophysics tends to do slightly better overall in that area, which is great if it attracts, you know, and it's a problem of a little bit of, you know, that the more women you have, the more women will join as well. I think that's just a fact. It's difficult to measure it precisely. The environment just changes a bit, and I think it just becomes more, you know, less about survival and just a bit more of a welcoming environment. You know, I don't believe anybody set out to make it otherwise, but the reality is that that's kind of how it was. So those are our numbers, and certainly in the AirSat team we've had fantastic female graduates and still students who are still studying. I think 2 out of 5 of our senior team are female in the AirSat team, and looking at the numbers, it was about 20% of that 50 are female.
Wow.
You know, and you know, one of my recent students, Sarah Walsh, she graduated and she works for OneWeb over in London, doing fantastically over there. So it's wonderful to see these graduates come out, you know, really brilliant people and do well. And then they come back then and give talks to our classes, and the whole thing then. You know, you can see, hopefully, and those things are very, very difficult to quantify, but you kind of feel it a bit, I think, you know, that they think, oh, maybe I can do that. So hopefully that's the case.
That's wonderful. That's wonderful. I'm just thinking, male or female, has there been an inspirational figure in your life, or somebody that really set you on your way or made you?
You know, it's an embarrassment of riches, really, to be honest. I mean, there's so many. I don't think I could pick out a person. There's so many colleagues who've been in totally different ways, you know, from the women in sciences side, from the technical side, from, you know, the international side. There were so many. And we have quite a history, actually, in Ireland of females working in gamma ray astrophysics. We have, you know, myself and Lorraine are here in Ireland, but we have, you know, Valerie Connaughton, she works at NASA, Julie McHenry, and also Deirdre Horan. These are all, you know, that's 5 just there, not even counting those coming after us. You know, and Julie is, you know, really very senior in NASA, and she came back and got a medal in UCD, and she's actually our named person on our Space Science and Technology medal for the best graduate every year. So we keep that circle, and it's wonderful to meet them, you know, and you can always ask people for advice. You know, there are a lot of people that I've asked for advice down through the years. I couldn't even list them, you know, who have listened to my presentations for job interviews and this type of thing, you know, and given you know, honest advice and on their experience, and that stuff is really invaluable.
This isn't an easy question either, and I'm sure there've been many, but if you could pick out a career highlight?
Yeah, gosh. I suppose if I were just to pick one, it would probably be so when I was in the Max Planck, I joined the Fermi team, and I also joined another team which was more on the, you know, follow-up using optical ground-based telescopes. That was quite new for me at the time. And then, you know, one evening quite late at night, I thought, oh, why don't we put in a European Southern Observatory proposal to follow up? So to point, they have massive telescopes, 8-metre telescopes down in Chile. And Ireland actually a recent member of the European Southern Observatory, which is fantastic. But at the time we weren't, and I was in Germany anyway, so I said to myself, well, maybe I'll write a proposal on this. And I spoke to colleagues, and they were very encouraging. And I like to be organised, and I didn't leave myself an enormous amount of time for this particular one because I didn't think of it in time. And I remember submitting the proposal, you know, literally at the deadline, which is something I don't typically do, and I couldn't believe that we'd gotten it in. And then we got the time. And then there were a number of the types of events that these were very high energy events that were detected by the Fermi detectors are on the side and also on the top. There's called the Large Area Telescope. It detects higher energy events. So 4 came through that produced these high energy events very soon after my proposal went in. And then there was a bit of a gap, so I was extremely lucky that I had, because the proposal time is only 6 months. So you have to hope in that 6 months the thing that you want happens. You know, and I really enjoyed working on that one, following it up. It was challenging. And I had great colleagues in the Max Planck at the time, and that's probably a paper that I really enjoyed working on. You know, there were a lot of really great results from the Fermi team as well, but that one was a little bit separate. It was a bit, and I liked it because it involved, you know, doing something that I hadn't normally done. And from that point of view, and having a bit of luck is also good. The events happened, so the proposal started on the 1st of September, I think. Then we had 4 events in quick succession. Amazing. So quite lucky. Yeah. And they were really interesting ones as well. So yeah, you need to be in the right place, but also luck.
Yeah, you always need the luck, let's face it. So again, this is a question we always ask, but could you tell us something about yourself that people might not expect?
Gosh, I don't know. I find these things hard.
I know.
I think that might be hard. But the whole experience of doing the interview as well. I don't know. I think maybe like in terms of career, you know, that I never did internships. I spent my summers, you know, working in Germany, I went to Edinburgh, I went on a J1, all of those things. I didn't, you know, do, and I think there's a lot of pressure maybe now on students to do that. Mm-hmm. I think it's wonderful if you can do it, to take the time, travel, do a different job, and those skills will help you in ways that you hadn't expected. You know, having to manage a shop in New Jersey can help you a lot in what you do in the future. And I think it's really important that students have a bit of that time as well. Yeah. There's an awful lot of pressure on people, I think, you know, coming out of school and then it's college. And, you know, it'd just be nice if people could take the time to also, you know, relax and enjoy and travel while you can, because when you start working, you don't have as much opportunity. So, yeah.
You may have answered my final question there already, but, you know, for I suppose specifically aspiring physics or astrophysics students, researchers, if you had to give one piece of advice?
I think probably it would be that it's okay not to know something. And that's something that actually takes a long time for people to realise. They think they should know everything, and you're not going to know everything after an undergraduate degree, even if you've done very well. And if you're finding it hard, it's because it is hard. And it's okay for it to be hard, and not to expect that you can do everything immediately, and not to be disheartened by that. It's, you know, people can find out that it's not for them, and that's also good, but not to be disheartened by, you know, if you were finding your second year quantum mechanics course hard, it's because quantum mechanics is hard. Sure. And you're not alone there. And, you know, persevering with that and doing the problem sheets and, you know, going into postgrad, these things are difficult and they're really enjoyable. But it's okay not to know things. It's okay to ask. It's okay to say, I actually don't know, but this is what I think. And that's fine. And I think that is one of the skills that's probably the hardest thing because people have come out with a degree, they've done well. They don't really like necessarily to sometimes admit that they don't know things. And I think it's a skill that can really help, because then you'll be able to ask a lot more questions. You know, you might find yourself sitting there in a meeting thinking, you know, I really don't know what this person's talking about. And then someone who's much more senior than you will ask the question that you thought. And then you'll think, right, it was okay to ask that. But I didn't have the confidence to ask it in case it was, you know, too obvious. Yeah. So I think that's the bit of advice that I would probably...
It's a really good piece of advice in any walk of life, in my view. But
yeah, it's hard though when you're, you know, if you're not that confident, it's hard to you know, admit that or to ask a question sometimes. So.
Time has flown by, but Professor Sheila McBreen, an absolute joy to talk to you. Always so interesting to talk about the area of space, and I can't wait to hear more and see what goes on in the next couple of years. So thank you so much for being with us.
Thank you very much for having me.